Alright, in this session we're going to talk about the G2 clockwise arcs. So you can see I have drawn a 4x4 square and I have added some radii on the corner. So this will be a 1/2 inch and a 1 inch and a 1/2 inch. So far we've learned how to code straight line moves with a G1 on that line. Once we get to a intersection where we start a arc, like for instance this intersection right here on the top right, we're going to have to do a G2 line. Then at the G2 line we'll do a clockwise arc, and then we go right back into a straight line. We'll do another G2 arc followed by a straight line, so that'll be a G1, then again G2 followed by a G1. So I've added a tool path that is offset a 1/4 inch from the part geometry, and that is a representation of the center line of the tool, which will be again a 1/2 inch. Then also I have added the X and Y values of each intersection just to kind of simplify it here for this first session. So as you can see, we have a 1/2 inch radius in this top corner, a 1 inch radius in the right lower, and then a 1/2 inch radius again in the lower left hand corner. So as we start our tool path, I'm going to go ahead and single block through it. We do our approach again, or our lead-in move, so away from the part. Now don't confuse this purple line with the excess stock. That's actually a representation of the center line of the tool path in this case. Alright, so the first intersection we come to is after we have completed the straight line move and we're getting ready to do a clockwise arc at the 1/2 inch radius. Now I want you to realize that even though this is a 1/2 inch radius on the part, the tool is offset a 1/4 inch. So the radius that the tool is actually swinging is a 3/4 inch radius. So that would be a 1/2 inch actual radius plus half the diameter of the tool, which is a 1/4 inch. So the actual radius of the tool path is going to be 0.750. Okay, so we're going to complete that move. So that will be our G2 line. And right at the end of the G2 line, at the end of that radius, we start back with a straight line. So in our code, the next line will start with a G1. We complete that move until we are at the start point or tangent point of the next radius, which is a 1 inch with an offset tool path of a 1/4 inch. So the radius that it is swinging is 1 inch 250. So we're going to complete that move. Then we're going to do a G1 to the next radius, and then the next line will be another G2 with a radius of 0.750, and then we complete our move to the end point as a G1 move. Alright, so the next thing we're going to do is just take a look at this tool path and let's see how it transitions between G1 and G2 and the rest of the format. Alright, so we're looking at a complete program of that segment, starting out with our percent sign, followed by the O, followed by 3 zeros, program number 2, and a description of the program itself. Then we're going to do tool number 1 with the description 1/2 inch flat end mill, so we know we are offsetting our tool path half of the 1/2 inch end mill by 250. Okay. Then this is our safety line, and we follow that by the description of the tool path. So this will be a finished tool path around that part. Followed by a line where we pick up our tool number 1 with an M6. The M6 is the command for a tool change. Next line, GO is a rapid move, and that I should actually say G0. Okay, G90 puts it in absolute mode. G54 is the work offset we're going to make active, and we're going to wrap it in position to an X minus a 1/2 inch, Y a 1/4 inch. And we're going to turn the spindle on to 2000 RPM clockwise rotation. Then the next line, we have a G43 line. That's where the program is looking at the tool data page. The G43 is actually looking at that page. Then H1 looks at line 1 where tool 1 information is located, pulls in that offset and uses that to wrap it in position 1 inch above the part. M8 at that point turns the flood coolant on. Then right there we're going to wrap it to 100 thousandths above the part, and then we start with a feed move. We don't want to necessarily wrap it into position below the top of our part. We're going to do a G1 Z minus 0.5. Remember, anytime you mention your first G1, you have to have a feed rate on that same line. So we're going to 1/2 inch depth. Then the G1 is modal until it's changed. So the very next line, we're actually moving to an X 3.5 at Y250. So we're staying at Y250. Yeah, so there's no need to call that out again. So G1 is modal and Y.250 is modal. So the only thing that's changing is the X value. We're changing the feed rate to 25 inches a minute. And then we end up at the tangency point of our arc. So the next move we make is a clockwise arc. So that is a G2. And the end point of that arc is an X 4 inches 250, Y minus 0.5. So it generates a 1/2 inch radius on the part, but the actual tool path swings a 0.7 or 750 thousandths radius. Okay? Then we're making a straight line move to the next tangency point, and we are staying at X 4 inches 250, so that stays modal. So the only thing we're doing is making a Y move change. Yeah, we moved from Y minus 0.5 to Y minus 3 inches. So we're doing that in a straight line move. There's no need to repeat this feed because, again, that is modal. At that point, we're sitting at the tangency point of our next arc. So that is the lower right corner of the part where we have a 1 inch radius on that corner. So the G2 will do a clockwise arc with an end point of X 3 inches, Y minus 4 inches 250. Center line of the tool swings an arc of 1 inch 250. Then we make a straight line move from there to the next arc. The only thing that's changing is the X value, so that's the one we have to mention. And then we do another 1/2 inch radius on the part, meaning the tool is going to swing a 750 radius with an X minus 0.250, Y minus 3.5 endpoint. And then all we have left to do is just a straight line to complete the shape of the part where we end up at Y.250. Then the rest of the program is the footer information where we wrap it to a clearance plane of 1 inch above the part. We turn the spindle off with an M5, turn the coolant off with an M9. We home out in Z, home out in Y, and the M30 ends the program and rewinds it back to the top of the program. Okay, and then it's ready for another cycle start. So that is the format of the program. Take a close look at these G1 and G2 moves and look at the start of this video where you see the tool path and make sure those numbers makes sense to you. Alright, so look for an attachment PDF file and you'll have 2 exercises. This is the first one, 4 inches long, 2.5 inches wide, the XY origin in the top far left corner. The dotted line that you see is the center line of the tool. We're going to be using a 1/2 inch end mill, so this tool path is offset 250 thousandths, and that might help you to do any time in the future when you're trying to find your intersection points, is to go ahead and draw your offset line, which is really your tool path, and that might help you get your points straight. Okay, so the next one is this exercise, and that is 5 inches long, 2 inches wide. Notice that the X0 riser is in the middle this time, and you have 4 corner radii. Okay, same thing. Use a 1/2 inch end mill. Again, the dotted line is a representation of your tool path using a 1/2 inch tool, so it's offset a 1/4 inch. And so you'll find both of these exercises on a PDF. So use that to practice the G2 clockwise arc.